Hi all, and welcome to Chapter 9, which was all about functions that return values. Before we get started on the lecture exercises, I just wanted to point out this very important table from the textbook. It's in section 9.3, so if you haven't read the textbook yet, please take a read through Chapter 9 and pay special attention to this table. What it has is a list of different functions that are available to us in Python that are already programmed, so Python already knows about them, and we can use them in our programs to do certain things. So I'll go through them very, very quickly, and we'll use them throughout the rest of this course. The first two functions are min and max. So what those do is they take a list of numbers. So you pass those in as arguments to the function, and they'll return either the biggest one for max or the smallest one for min. So that's really nice that we don't have to program those types of functions ourselves. We can just use the existing ones in the Python library. Len is also a very, very useful function. It's short for length, and what it does is it returns the number of characters within any string. So you can pass in anything that's in double quotes or single quotes. That would be a string data type there. And it will count how many letters or numbers or characters are actually in between those single or double quotes and give you an integer value at the end of the day. Very helpful when we get into chapter 11, which has to do with control statements, and once we get into loops as well. If you're ever wondering what kind of data type a certain literal value is or a variable is, you can use this type type function, which will return the actual data type of whatever you pass in. So you can see some examples here, but you can try it out as well in your own processing. You'll notice that if you just used type in and of itself, you wouldn't see anything returned on the console. You actually have to print that command, same that you do with the length command. So that is an example of some nested function calls, which we'll see later on in the lecture exercises. These last three functions here are ways that we can convert data types to other data types. So for instance, if you had a float that you wanted to convert into an integer, so you knew it had, say, a 0.0 decimal and you needed that for some of your mathematical operations later on, you can use this int function to take whatever's passed in as an argument, and it will return the integer value of it if possible. So it works for floats, it works for strings when you have numbers that are encapsulated in quotes. It can be very useful, this type of function, and as well the float function, when you're getting user input. And so you'd see that a lot more in your later computer science classes. Float and string work similarly, so you can convert integers into floating point values, and for string you can convert ints into strings. So you can try those out on your own, and I just wanted to make sure you were aware of this table because it will come up in your assignments, and you will have to use these functions throughout the rest of the class. All right. Okay, let's get into some of our lecture exercises here. So as I mentioned, this chapter was all about functions that return some sort of value. So these exercises are asking us what value is returned by these function calls. So in all of them, we'll see this example of defining the function first and then a call to the function later on. Similar to what we have seen throughout this course so far, where we have to tell the computer what instructions it needs to associate with a function of whatever name we give. And then if we actually want to run that function, we need to tell the computer later on, hey, run that function and give it a value of whatever for my argument that I'm expecting up here. Okay. So we'll need to work through all of these examples and figure out what's actually going to be returned by this function call here is what it's talking about. This one that says that's after the function definition. So it's saying, okay, when we call cost with taxes and pass in a value of 25, what would get returned? And so what we need to do is take that value of 25 and give cost or assign cost that value. Then we would go through and trace through and say, okay, so to get final price here, cost would actually be 25.00, and it would be times that 1.1. And whatever that math works out to is what we would assign to final price. And then we're using that keyword return to say, okay, wherever this function was called, return whatever value is in this variable here to that place in the program. So it would effectively take this and return it right back to where it was called. So this is really helpful if you're like assigning a variable to it later on or whatever. It effectively is like saying 2 plus 2, and then you're saying take that whatever value of 2 plus 2 actually is and assign it to a variable. So something like this, var 2 plus 2. We know that the computer isn't going to store 2 plus 2 in var. It would actually store 4 in var, right? So it's going to evaluate this first. Same with when we do a function call. This gets evaluated, and then whatever is returned gets put in that place wherever we are in the program. So if there was a variable assignment before this, we wouldn't be just storing cost of taxes with inside the brackets 25. We would be storing whatever gets returned by that. So that would get evaluated first. In this case, I do not know off the top of my head what 25 times 1.1 is. So let's bust out the calculator and see. I have it here. 25.00 times 1.1 is, in this case it says 27.5. Now if you actually, really interestingly, if you actually run this on the computer, you'll get a very slightly different answer because it will have a whole slew of extra decimal places after it. And I think the last one will end up being like 4 or something like that. That's because computers have to represent precise numbers with a little bit of imprecision. So oftentimes, if you let it just have all the decimal places that a computer can store, it's going to have slightly off values when it comes to the very, very end of that, because there's just a little bit of imprecision associated with computational math. So you might see some of those types of things coming up. So that's going to be around, this one here should be around 27.5 is what gets returned. This one down here, again, we have our function definition up here. So telling the computer what this rect parameter actually is and what to do when it sees it. And then we have our function call down here. So our function call, we're passing in a value of 5 for W and 3 for L. And in this case, we have a return statement right here, but this equation that comes right after the return statement will get evaluated before that return actually happens. So what it's going to do is it's going to calculate 2, times 5 was our value for W that we passed in, plus 2 times L, which is the value of 3 that we passed in. And these bits here get done first before the addition, so that would be 10 plus 6. And finally, this should get simplified to 16. And that's just following typical BEDMAS rules. So the value that should get returned by this function here when we pass in 5 and 3 should be 16. All right, we have these two here, which are a little bit more tricky. So again, we still have our function definition. So remember, function definition, def keyword, function name, and then any parameters would go in those brackets there. We have our function call, which in this case, since we have no parameters that we're passing in, we don't pass in anything here. And when we do this, what happens is we get the string Python assigned to this variable language, and then on the console, it's going to print out the value of whatever's in this variable. So in this case, that would be Python, is named after a comedy series. Now, although this is printing to the console, so this would all show up on our console, it's not actually generating output. It's generating something that's happening on our system. So similarly to when we were working in processing and we're drawing rectangles and lines and circles and things are following our mouse, that's not necessarily function output just because we see something happening. Just because we're printing something to the console or we're showing text on our canvas doesn't mean that we're seeing function output. Function output and system behavior are two separate things. Function output only happens when we have that return keyword. So if you don't see the return keyword in a function definition, that function call doesn't return any values. So that's a really good way to kind of have a quick gut check on that. So this one here actually doesn't return anything. This one here is kind of similar. So we have our function definition, we have our call, we are passing in a string ha and a number 5. So our message in this case is ha, and the n repeats is 5. And in this case, it's going to print that message and then times 5. So does anybody remember what that would do for a string? Da, da, da. If you answered, it's going to repeat that however many times that you multiplied it by, you'd be correct. So just for demonstration purposes, I'll put that in here. Ha times 5, just so you can see. And when we run that, you get ha, 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 ha 5 times. So that's a nice little string operator that we have, what we talked about in an earlier chapter. In this case, we do see that return keyword, so we're thinking, maybe this function does return something. But because there's nothing after that return, it's actually not returning anything. What's really being returned is this value called null, which represents nothing in computer science. So in this one as well, we would say nothing is being returned. Okay, now we have some functions that we're supposed to write. The first one here is this one called area from dimensions, which has 2 parameters, w and h, and returns the area of the rectangle. So the w parameter is going to be the width of our rectangle, and the h parameter is going to be the height of our rectangle. So just as a reminder, to get area, if you don't know how to, all you need to do is multiply the width times the height. And if you ever are reading one of our questions in our class and you're like, oh, I don't remember how to do that specific math thing, a quick Google will help you out there, or you can post about it in the discussion boards. So I'll just bring over my processing here. And what we want to do is first start out with our special keyword that tells us we are defining a function, which of course is def. We're then going to finish our function header by using that title that it tells us to right here in the slides. So rect underscore area underscore from underscore dims. And then we pass in W and H. Remember, when we're finishing our function header, you always have to have that colon. And then any of the instructions we want that are inside of that function have to be tabbed over. Now there's a couple of different ways we could do this. We could make a variable called area. We could assign it the value of our width times our height. And then we could, after that, return area. That's a perfectly fine way of doing it. Now I'm just going to comment these two out to show you if you wanted to do this all in one line, you could as well. So here you would just say the return keyword, and then you just do W times H. So remember this part here, this W times H, will get evaluated first before the function actually returns it. So it wouldn't just return W times H, it would return whatever the value of W we passed in multiplied by whatever the value of H we passed in. And whatever that answer would be is what would actually get returned. And remember, this is just the function definition, so we wouldn't be actually calling it at all in this situation. If we wanted to call it, we would have to do a new line tabbed over to the same indent that we would see the def being tabbed over and actually call it. This isn't part of the assignment question, so we wouldn't have to do this for a solution, but if you wanted to test it, you could then pass in a value for W and the value for H that you wanted to see. And if you actually wanted to see what was returned, you'd have to wrap that all in a print function, because this will just return. Just because it's returning doesn't mean the computer knows we want it displayed. We'd have to tell the computer, hey, display whatever's returned from here. And it will figure that all out for us. So we could run this and then we see it's 25. All right. So for B, we have a very similar problem. So same, we want to build up a function, but instead of it passing just the width and the height, we're passing X and Y coordinates. So we'll think about it like this. We have our rectangle. Our top left here is going to be our first two coordinates that we pass in, so x and y. And the bottom right over here is going to be these two coordinates that we pass in. So we need to be able to figure out from that what is our width and what is our height. And so one way to do that, if you're thinking width, you're almost always thinking x and y's. So to figure out what we would do, all you need to do is say, okay, so whatever this value is minus this value will actually give us this value here. So if we wanted to figure that out, it would just be BRX minus TLX. And then similarly for height, you start with the one that's furthest down, which would be BRY minus TLY would give you that height. And if you don't believe me, very fine, great to be a skeptic. What I'd recommend you do is map it out. Say that this was a 5x5 grid or whatever that you wanted. Figure out what the top left coordinates would be. Figure out what the bottom right coordinates would be. If it's on a grid, you can figure out what the width and the height would actually be, and convince yourself that these equations actually give you the height and the width of the square. Okay. So that's the tricky part of that question. Once you have that, it's actually quite easy to code it up. And I'm going to just start with the same function that we had before. So I'm just going to get rid of that. We wanted to call this chords this time instead. And we have our top right x. Mine's not going to be far enough out, so I'm going to make this quite big and then I'll shrink it down after. Our top right y. Our bottom, top left, right? This is where I miss in person, where you would all be yelling at me and telling me I goofed it up. Bottom right y and no h. I like spaces, so I always put spaces in between my arguments, but you don't have to. And then all we need to do is calculate what those different things would be. So we could do it all in one line, which would look like this. Actually, I'll do it separating. I think it's a little easier to understand. Then I'll show you what the one line would look like. So if we wanted to say, okay, first we need to calculate our width. Let's call it W. And that, remember we said, if I just move this over slightly, our width is our bottom right x, which we pass in, minus our top left x. So bottom right x minus top left x. And our height is this equation over here, bottom right y minus top left y. Bottom right y, top left y. And then we could have another one where we say area, which would just again be width times height, and then return area. So this is a completely fine way of doing it. It actually gives you a lot of information, a lot of internal documentation, just because of how you've split everything up. I'm a little more verbose when it comes to my programming, so I am more likely to write something like this. But you could also write this all in one or some combination in between the two, where you would say, okay, we need to calculate our width. Width is BRX minus TLX times BRY minus TLY. I'll just open this up so you can see it a bit more. And so we just comment all this out because we wouldn't need to do both of them. It would just be one or the other. You can see that this one here, we have our width in the first bracket, so that would get calculated first. Our height in the second bracket, so that would get calculated next. Then those two answers would get multiplied together to give us our area, and that would be returned. So either or is fine. If you're doing it like this, you probably want to add some single comment in there, just giving a little bit more of a description. We truly should be adding in our doc strings anyways, which we haven't been doing. So, there's a little bit we could do better in terms of the documentation here. But you can see some examples of those doc strings if you want to practice yours in the solutions on the course website as well. All right. Oops, scrolled too far. Okay, and now this is the final one here, which I'm going to leave you to do on your own because it kind of combines all of the different things that we talked about. And you can check out the solution on the course website, like I mentioned. So you'll be writing a function called screen space, and it will take in all of these parameters. So the width and the height of the entire screen, so that would be all the way around. And then it's going to return the usable part of the screen, so which is this blue space right here. The other two parameters are going to be the title height, so that's going to be this height here. And then the controls height, which would be this height here. So to get the screen space, what you need to do is take your total area that you would get from the whole screen, figure out what the height of that is, right? And then you're going to subtract your title bar height and your controls height from that. And that should give you the usable height that you have. Then you can multiply that by your width, and you'd get your total area of your blue space in here, right? So the hard part is figuring out how do I actually get the math and use all the variables we have to figure out how I can get that area at the end of the day. And so again, you'll take your total height that you have here, and you're going to subtract your title height. I'm just going to call that TH for now, and your controls height, to find out this height down here, which is the blue space height. We'll call that blue height. And then you'll take that and you're going to multiply it by your width to get your total area of your screen space, and that will be what you return, okay? So see if you can code that up. Check your solution with what's in the lecture exercise solutions. All right, for this one here, we're going to be guessing using some tracing through our programs what will actually be printed to the console by the following programs. So this first one here, again, we have our function definition, and then we have the call to it here. In our function, we're looking at taking in 3 different values. We find the maximum of those 3 values and the smallest of those 3 values, or the largest of those 3 values and the smallest of those 3 values, and subtract between them, and then return whatever that value is. So when we're calling it, we're passing in a value of 3, minus 5, and 0. Our largest is going to be 3. Our smallest is going to be 5. So if we're thinking 3 minus, smallest is negative 5. Negative 5, what does that actually get? Well, remember, if we have a negative minus a negative, that's actually gets added. So that's going to be a value of 8. And if you don't believe me, practice coding this up, running it, and seeing if you get that value as well. Here again, we have another function definition. This case is returning the max of 0 or the minimum of whatever we passed in at 100. So that's a little confusing. It has a bit of a nested function call in there. So what happens first is we always move to the interior most function call, and that would get evaluated first. So when you're looking at this, first thing you're going to do is going, okay, so very first we want to move all the way in as we can into the most inner bracket. So this min x or 100 is going to get called first. And what's that saying is whatever's smaller, either the number we passed in or 100, that will replace right here. Then we want to take whatever larger, whatever gets returned from this min function, or 0. And so in this case, we're passing in 150 into x. So 150 or 100, what's smaller? In this case, it's 100. And then the maximum of 0 or 100, in this case, 100 will be returned. I'd love for you to play around with this function a little bit and try some different values of x's, figure out what you think should be returned, and then see if you can actually trace through that program properly, and when you run it, do you get the value that you thought would be returned. And then we have this program here. So this one here is a program called overflow, or a function called overflow that takes in one parameter, password. We have a variable called maxChars, which has a value of 10. And in this one, we're assigning the variable extra to try to see how many extra characters over 10 does it have, does whatever we passed in have. So again, we have some nested function calls here. So go into the very inner one. The first one that would get evaluated is this len password. So if you'll remember from the beginning of the video, len is going to count how many characters are stored or are in the string that's stored in that variable. So whatever that's going to be is going to be returned as a number. We're then going to subtract the maximum number of characters from that and return either 0 if it's the largest. So if the password was smaller than the maximum number of characters, then 0 would be returned. Or if it's larger than the maximum number of characters, however much larger it is, would get returned. So in this case, we are calling it with this string me love cookies that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters. So we would expect this to return 3. And in this case, if you go through it all, so we have our max characters 10, length the password would be 13. 13 minus 10 is, this is 10 here, is 3. 3 is larger than 0, so 3 should be the value that gets returned here. We're then printing your password is too long by, and then we're using this variable extra here. What I want you to think about is, can we use this variable here? Does this work properly? Will this actually get displayed to the console? What do you think? Remember, this has to go back into what we know about scoping with programs and global variables, which we learned about. So let's write this all out. I'm just going to write it out. Ooh, it's going to be hard for me to see it all. Let's see if I can get it like this. Sure. We'll practice our typing it out. So def overflow, password, max chars is 10, extra is max. The typing today leaves something to be desired. Length of password minus max chars. Yeah, I got it. I was just checking here to make sure I had all my brackets lined up. And so you'll see if you mouse over that one, it shows you the one it matches with, which is quite a nice feature. And then return extra. And over here, overflow, me love cookies. This is not my password, FYI. Don't try to hack me. Print your password is too long by. Print extra. And then print characters. Now if we run this, what do we think will happen? Your password is too long, Pi. Looks like it's missing stuff. It's missing all sorts of stuff. And it's not telling us why it's not finishing that part here. And the reason why is because we actually have only defined extra up in this function. It's not a global variable. So if we wanted it in this scope as well, we'd also need a variable here that's capturing our output of our function. And then if I run it, I get the rest of it. And so you'll note it wasn't giving us an error, but it also wasn't printing this characters string that we wanted. So that kind of gives you a bit of a hint as to where that bug might have been. Sometimes it's a little tricky to find the bugs in our programs. It can be really frustrating. And that's when things like help hours can come into hand, or tutorial hours. You can come by, we can take a look, and we can help you figure out what's going wrong. So here's the next exercise here. We have a function called update x. We, inside of there, say x equals x plus 2. Then outside of our function, we give x a value of 5. We call update x, and then we print it. So the question here is this math that's happening in here, is it happening for the whole program or just for this function? We're not returning anything, so nothing is coming out of that function. Is x a global variable? I'll let you try to decide that while I type this out, and then we can show you exactly what is happening here. I wish I had a live poll that I could have right now that said, what do you think? Will x equal 5 or will it equal 7? Because if it equals 5 when we print it, we know that this is the scope of x, and that what happens over here isn't going to impact this x here. If it's 7, then we know that the function is actually updating that x value. So x plus 2 have this over. X equals 5, update X, print X. So 3, 2, 1, what do we think? 5. So again, similar to the other one, nothing is being returned here. We're not saving that in a variable outside of the function. So this is happening, but it effectively dies once the function has ran. It doesn't persist anywhere else for us to use because it's not a global variable. We could make it a global variable, and you can try doing that on your own if you want some practice with that, and then it would actually be a value of 7. All right, so that's it for nested function calls. We're not going to be doing chapter 10. Chapter 10 is all about libraries, and those only recently started working with processing 4. You can do it on your own. The instructions to install a library are slightly different, so if you're having problems with that, just let me know. It's same things, it's just some of the labels are different is all. But you can work through that chapter on your own. It's completely optional. You won't be tested on it at all. Okay? So the next chapter you'll see me in is chapter 11.